The experiment apparatus used in this experiment is an open type of a subsonic wind tunnel. The basic wind tunnel consists of a fiberglass contraction and diffuser section with a clear acrylic parallel test section of 300 mm octagonal section. The wind tunnel essentially consists of the following: a contraction cone chamber that includes an aluminum honeycomb flow straightener, a test and measurement section, a diffuser, a fan and AC motor, an inclined manometer calibrated to indicate the airspeed in meters per second. Air enters the test section through a carefully designed contraction cone chamber. The contraction cone chamber forces a large volume of air through a small opening in order to increase the airspeed in the tunnel. The airspeed accelerates to roughly 3 times the original velocity in the cone opening. The contraction cone chamber contains an aluminum honeycomb flow straightener designed to ensure that the flow is steady in both magnitude and direction, and it has a flat transverse speed profile. All models are to be tested in the clear acrylic parallel test and measurement section. To fix and exchange the testing models, the testing section can be opened and closed using a sliding guide. A low-angle diffuser at the outlet end contributes to flow stability in the test section. It also increases air volume in order to reduce the airspeed as it exits the tunnel. A 5-bladed fan driven by an AC motor is located at the outlet of the diffuser section. The motor speed control unit allows smooth control of airspeed. To reduce airflow turbulence, air is drawn in the tunnel instead of blowing air in the tunnel. That allows greater control of the airflow through the tunnel. The tunnel airspeed is indicated directly on an inclined manometer calibrated in meters per second, connected to a manifold surrounding the upstream end of the test section. 4 equally spaced static orifices connected to the manifold minimize the possibility of interference effects from a model mounted in the test section. The wind tunnel is equipped with a 2-component aerodynamic balance that measures both the lift and the drag components of the forces exerted on the model under testing. The 2-component balance consists of a pair of balances supported on knife edges on mutually perpendicular axes parallel to and normal to the axial center of the tunnel. Lift and drag components of force exerted on the models under testing are balanced by sliding 2 weights along the arms of the balance until a state of null deflection is reached. Graduations in Newton units of force allow lift and drag to be read directly. The angle of attack is one of the important testing parameters and can be set for the tests using a protractor fixed on top of the 2-component balance. 5 drag models are included in this experiment that have the same equatorial diameter: sphere, convex to air flow direction, concave to air flow direction, circular disc, streamlined shape, and spare support rod for drag calibration purposes. In this experiment, the similar equatorial diameter drag models will be tested at different airspeeds using 0 angle of attack to have a direct comparison of their drag coefficients. To study the drag and lift coefficients at different angles of attack, NACA 0015 aerofoil is used in this experiment. This aerofoil is equipped with an adjustable leading edge slot and trailing edge flap. 2 series of tests will be performed on the aerofoil using closed flap and open flap arrangements, respectively.